If you are asked to integrate this, namely, what is the integral of 1 over x times the quantity x to the 2023 power plus 1 from 0 to 100, how would you do it? Hello, welcome back to the Quant Plus YouTube channel. Today, we're going to be discussing this integral. So, as the title alludes to, if we apply two fairly common integration techniques which are covered in most first-year calculus courses, namely partial fraction decomposition and u-substitution, we can take down this relatively intimidating-looking integral. So first, I'm going to do a bit of algebra. First, I'm going to write out a over x plus b times x to the 2022 power over x to the power of 2023 plus 1. From here, I'm going to create a common denominator and write this as a times x to the 2023 power plus 1 plus x times b to the 2022 power over a common denominator of x times x to the 2023 power plus 1. Then from here, I'm going to expand the parentheses in the numerator and write it as a times x to the 2023 power plus a plus, oops, I forgot an x here, b times x to the 2023 power over x times x to the 2023 plus 1. Then, by setting this new expression equal to the integrand, I get the following set of equations. A plus b equals 0 because a and b are the coefficients of x to the 2023 power, and in the numerator of the integrand we don't have any terms with x to the power of 2023, and a equals 1 because a is a constant term and we have the value 1 in our integrand. Therefore, we can say 1 plus b equals 0 and b equals negative 1. Now, this allows us to rewrite this integral as the integral from 0 to 100 of 1 over x minus x to the 2022 over x to the 2023 plus 1 dx. From here, we can split this into two separate integrals, right? Because remember that if you're adding or subtracting inside your integral, right, in terms of two separate terms, you're allowed to split it into two separate integrals. So we have this integral minus the integral from 0 to 100 of x to the 2022 power over x to the 2023 power plus 1 dx. The first integral on the left appears to be a fairly standard integral, and you end up with the natural log of the absolute value of x evaluated at 0 and 100. For the second integral, right, we're going to consider u-substitution, and more specifically, we're going to write u is equal to x to the 2023 power plus 1. And du is 2023 times x to the 2022 power dx. So we might want to write dx as du over 2023 x to the 2022. Now, substituting this back in, we end up with minus the integral of x to the 2022 over x to the 2023 plus 1 times du over 2023 x to the power of 2022. The other thing I want to do is I want to rewrite my bounds. So if x is going from 0 to 100, well, if I plug in x equals 0 into this expression for u, then 0 to the 2023 power is still 0, and 0 plus 1 is 1. That means our lower bound is 1. If I plug in x as 100, then our upper bound is 100 to the 2023 power plus 1. And then from here, right, notice how this term and this term cancel each other out, and that this term in the denominator is what we labeled as u, which means that we get to the following: natural log of the absolute value of x from 0 to 100 minus the integral from 1 to 100 to the 2023 power plus 1 of 1 over u du. We're going to keep this as the natural log of absolute value of x evaluated at 0 and 100 minus the natural log of the absolute value of u from 1 to 100 to the power of 2023 plus 1. Now that we're at the evaluation step, you might look at this first integral and say, well, hey, the natural log of 0 doesn't exist. But what I would remind you is that we're really considering the limit as x approaches 0 from the right of natural log of absolute value of x. And if we look at this graphically, we can see that this is approaching negative infinity. So that means that we end up with the natural log of 100 minus negative infinity, then minus natural log of 100 to the 2023 power plus 1 minus the natural log of 1. So the natural log of 1 is 0. And that means that this final term here will cancel out. What we're left with is the natural log of 100 plus infinity minus the natural log of 100 to the power of 2023 plus 1. Now, we can combine the natural log terms together by the natural log rules, and you'd get something close to 0. But because we have plus infinity, this entire integral goes to infinity. And that tells us that this integral diverges. So, if you're interested in more content like this, please support the channel by liking and subscribing, or I should say liking this video and subscribing. And if you're interested in one-on-one tutoring sessions, please follow the link in the description. Have a great day.